minutes after class started. Sorry about that. I just wanted to give you a complete heads up for everything. All right, so we're going to do applications and models, growth and decay, and compound interest. So basically, we're just going to be doing word problems that involve growth and decay, basically, of money or other things. And so it uses exponentials, but it's not terribly hard to crunch through this. And so here, this is what population. So given a given population for a function, so this could be a population of like people or bacteria or animals. A very simple kind of population growth is this, and is this function. And according to this function, here we're going to have some population P naught whenever we start our time. It's going to just be exponential growth, right? Because it's e to some k to some t, right? So here's our t, here will be our population. And so this is what the graph looks like. And so when time equals 0, whenever we define 0, we're going to define our population here. And this, and so we kind of define it this way with all that, but we can leave that for now. All right, so some kind of population growth. And this can be more than just quote unquote living populations. You can have, things propagate and, accounts or something, you have so much growth per turn, or it can mean a lot of things. So here, P naught is the initial population. So population at time 0. So whatever that is, you just say that's P naught. P of t, so this is, our population at after a certain time. P naught is just our initial population. E is that 2-point certain natural number, right? 2-point, that long thing we did. K is our exponential growth rate, and T is the amount in time. And so the growth rate and time must be in the same unit, so please make sure you have the units match. All right, so let's look at this. In 2009, the population of Mexico was about 111.2 million. And the exponential growth rate was 1.13% per year. So find the so here we want to find the function. So here we're just going to label everything. So P of t is still going to be population of t. Here, our function. Our function will be the following. And so here we'll have 1.2. So that's our initial population in millions. So we'll just know it's in millions. I mean, I could put all the zeros, but let's just leave it and say it's in millions. E, which is our natural number. And then we're going to have 0. And then it'll be 0.01. So I'm not going to lie, I stole this problem from the little slides. So I was like, it's fine, right? It's wrong in the slides. Oh man, I don't even know why. So we're just gonna have to go with it. All right, so here's our population function. So here's our P naught. This is our exponential growth rate, and so you have to convert percentage into this, and here our time. For t is equal to 2000, so t equal to 0 implies 2009. Okay, so we're starting time 0 at 2009. So we want to find the population at 2014, so that's going to be time equals to 5. So that's what that means, just t equals 5. So let's do that. So P5 is equal to 1.12 e to the 0.013 times 5. And we're just going to crunch that through a calculator. Hello, there we go, let's just crunch it through a calculator. I need to open a calculator and not show attendance because I always do that. And I always have to cut the video. All right, so let's just crunch this to a calculator. So here, remember E. Let's see if this is giving me what E is. It's E the character. What if I want the mathematical constant? Here, remember it's 2.71. 82, yeah, this is our E, remember? And so here we're just going to have 11.2 times. Here we're going to raise it to the a quantity of 0.013 times 5, because that's where we're at, and we get here. We'll get about 1176. Okay. All right, so here we'll have 107.6 million people. Okay, so this will be million people. Technically, it's a word problem. You write it as it's estimated in 2014 you'll have this many. I'm not going to worry about it for this section. Just get through it. Okay. And then how long until the population doubles? And so how are we going to figure out that? So here, so I want to find out how long until the population doubles. So the population is going to be 2 times the initial population. So I want 2 times P naught equals P naught e to, here we'll have the same growth rate, 1.1 or 0.0113 times T. And so notice we just want to know when we double our population. And notice it doesn't even matter. I mean, I could write in 222 million point 4 or 222.4 million, just double this. But notice here, this cancels and I just have 2 equals e to the 0.0113t. So this always ends up being true. And I'll show you that in a second. And so here, if I wanted to solve this, what do? I take the natural log of both sides, right? So I have ln of 2 equals e, ln of e to the 0.0113t. Well, that means ln of 2 equals 0.0113 of t. So that means t equals ln of 2 over 0.0113. And we'll just crunch through that number. In fact, I have it pre-crunched for you. And so that means t is roughly equal 61.3. So it'll be 61.3 years after 2009. So roughly, so it'll be roughly 27. So it'd be roughly 2070.3. I guess that doesn't make any sense. So just say 63 years afterwards, right? After 2009. Okay. And so basically it just, the whole point of this just kind of mess with this. So I'll let you write this down and then I'll switch to the next page. Okay. I'll post these videos Tuesday. So let's go ahead and look at the next one. So let's look at money. So interest compounded continuously. So here's the same thing where this is just the principal, this is the balance after t years, this is and the interest rate. So it's the same function, the exact same function. All right, so let's work on some things a little bit differently and figure out some stuff. All right, so here, once again, we'll solve a problem. And so suppose that you have 2,000 invested at some rate k. You don't know what that is. It's compound 10 continuously and grows to $2,504.65 after 5 years. So what is the interest rate? And so here we just have a question. So we know it's 2,504.65 after 5 years. We know we put in $2,000. We don't know what our interest rate is, but we know how much time passed, 5 years. And so we just solve this for k. Well, how do we solve this for k? Well, you just divide these two. So I'm going to divide this by this. And so I'll have e. So remember what our goals were. We want to put the exponential on one side and everything else on the other. So here we just do this, e to the k5. Next thing we want to do is take the log of both sides. So I have log of 250.65 over 2,000 equals ln of e to the k5, which this, of course, just equals k5, or 5k, I guess. And then so k is equal to 5 times, or nope, I'm a liar. I was a liar. K is equal to ln of 250.65 over 2,000 divided by 5. And you just crunch this through a calculator. And if you crunch this through a calculator, you're going to get the following. 0.045. And so you have k is equal to, and so what does this really mean? My interest rate was about 4.5%. Okay. So here's A. So here I solved that. Find the exponential growth function. So now, oops, that is a funny looking A. So here's A. So B, now we have that, we can write our function. So we have P naught, or so P of T is equal to 2,000, because that's how much we put in, E to our K. So we figured out what K is. Oops, I'm putting one too many zeros. And we figured out, and then we'll have T. So this is our exponential function. So we have, going back to here, we put in $2,000, so that's our P naught. This is the balance after 2 years. This is 2 years, and this is our interest. So we just put it into that. All right, after we put it in this, we want to find out how long until, how long after 10 years. So we'll have P of 10 is equal to 2,000 e to the 0.045, and then we're just going to times that by 10. We just crunch that through a calculator. Yeah, I'm going to actually show you when we crunch in a number again. Let's show more number crunching. All right, so in this case, this is just 2,000. 2,000. Here we have our interest rate here is now 4.5 or 0.45, and we'll go for 10 years this time. And so there's our answer, 31,000. 3,100, I guess, and $36.62. So, all right, so we just crunch that through a calculator. This equals 3136.62. And then we want to find out how long till it doubles. And so in this case, let's just go ahead and do that. So this would be 4,000 is doubled of the 2,000 equals e to the, and notice this is 2 p naught equals p naught e to the 0.045 t. This is 0.045 t. All right, so if we solve this, either case, we're going to have 2 here, because I divide out, either I cross off the 2 p naughts, or I divide 2,000 by 4,000. I'm going to get 2 equals e to the 0.045 t. You take the log of both sides. Oops, I didn't take the log. 0.045 t. And of course, this is 0.045 t. And so t equals ln of 2 over k, right? That's what this is. And we know what k is. It's 0.045 in this case. So that means t here is equal to 15.4 years. So in 15 years, it'll double its money, right? So we'll get double what you put in. So that's all of this. So I'll give you a second to copy that down. All right, just so we finish on time, let's go ahead and do the last set. All right, so I've been kind of trying to hint to this, but growth rate and doubling time. So the growth rate of a certain thing and the doubling time is related by, and it's always ln of 2. So if we were trying to find, this is what your homework asks, right? This is exactly what your homework asks. If you know the rate, it's 2 over time. If I know the doubling, so doubling time is a capital T, right? That's what they're going to use for capital. Capital T means the doubling time, time to double. So K times T equals ln of 2, or K, your growth rate is ln of 2 divided by your doubling time. So if you know the doubling time, you can figure out your growth rate. Or if you knew your rate, you can figure out how long it takes to double. So like here, this is exactly, we wanted to find time to double. So we took ln of 2 over K, right? ln of 2 over K, and that was our doubling time. Same thing here. We wanted to figure out time to double. That was ln of 2 over K. And so we found our doubling time. So now we'll do something a little bit different. Here I'm giving you, here I'm going to give you the doubling time. So population is now doubling every so many years. What's its growth rate? And so here, I just want to find what K is. And I know it's ln of 2. And then I know what my doubling time is. It's 25.8. So if I crunch this through a calculator, let's actually do one of these in a calculator. Yo ho ho, ho ho ho. ln of 2 divided by 25.8. I get 0.269 roughly. That's good enough. And so we can just say K is approximately 0.0269, or about 2.9, or 2 point, oops, that's a percent, right? And that's it. And you'll see one of your homework problems will say, here's the doubling rate, what's the constant, here's the constant, what's the doubling rate? And you just use these formulas. Okay, so that's the end of this one. So for a little star, so I know to cut my happy video.